Welcome to Pong Academy, where learning is free. This video is a shorter version of my presentation on temperature dissipation and effect on tensile strength of PETG and corrugated strips. In addition, eco-friendly cushioning materials are also discussed. First, I would like to thank my students, who worked many hours on this project. They are Anna, Miles, Edgar, Luciano, Brandon, Dahlia, and Mason. In a recent study on temperature dissipation of single-wall corrugated paperboard, the temperature dissipated very quickly from the moment the paperboard was removed from an environmental chamber. This creates a problem. The test sample is conditioned at certain temperature. However, it is tested at a different temperature. In this recent study, temperature was measured using an infrared camera. From the same recent study, compression strength of corrugated box varies depending on the temperature. For example, if a corrugated box is conditioned at 300 degrees Fahrenheit, but tested at 200 degrees Fahrenheit, the compression strength will be about 93 pounds lower. In this presentation, we repeated the same temperature dissipation study. However, PETG was used instead of corrugated paperboard. PETG is commonly used in medical device trays. A PETG sheet was conditioned for 24 hours with temperatures of -49, 50, 100, and 150 degrees Fahrenheit. The -49 degree instead of -50, because it was the lower limit the chamber could produce. The 150 degree was used as the maximum, because at 200 degree PETG warped and at 300 degree it melted. A temperature dissipation rate for PETG was produced, similar to that for corrugated paperboard in a previous study. Two curves were plotted, one for conditioning temperatures above ambient, and another for those below ambient. This slide compares the temperature dissipation rates of PETG and corrugated. PETG temperature converged to ambient temperature at about 4 minutes, while it took about 8 minutes for the corrugated. When conditioned at below ambient temperature, the dissipation rate was higher in both materials. However, PETG's rate was higher than the rate of corrugated. Since it was not practical to perform a compression test on PETG specimens, tensile test was used instead. A tensile test was performed on 1 by 6 inches PETG strips, as well as corrugated strips. As temperature rises, the tensile strength of both PETG and corrugated increases. The PETG tensile strength rises at the rate of 0.17 pounds per degree Fahrenheit, while the tensile strength of corrugated rises only about half the rate of PETG. The next part of this presentation is on shock absorption of eco-friendly materials. 4 materials were used in this study: rice hulls, biodegradable foam, crinkle paper, and mushroom board. Cushioning can be in loose fill form or board form. In this study, the loose fill cushioning materials were rice hulls, biodegradable foam, and crinkle paper. All were in loose form. The board form cushioning materials used in this study were rice hull paperboard, biodegradable paperboard, and mushroom board. The rice hull paperboard and biodegradable paperboard were made the same way as in several previous rice hull studies. A previous study showed that when 100% rice hulls were used, the board disintegrated. This also happened with biodegradable foam. Thus, paper was added into the wet pulps of biodegradable foam. Mushroom brick was purchased. Since biodegradable foam is made from starch and starch dissolves in water, a study was performed to see if biodegradable foam would dissolve under high humidity. In this case, 95% relative humidity was used, since it is the maximum the environmental chamber can produce. The pictures shown on this slide include the foam on day 1 with 61% relative humidity, day 4 at 95% humidity, and day 7 at 95% humidity with extended period of time. The percent moisture absorption after 7 days was only 10% without any disintegration of the foam. Foam pieces only shrank and became denser. A triaxial accelerometer with a 100 G maximum shock was used in this study. A base plank foam was used to cut down some shock, so the acceleration remained within 100 G. A cushioning material is placed between the base foam and accelerometer. The accelerometer was tightened up in a corrugated box to prevent horizontal and vertical movements. The box was dropped at 18-inch drop height 20 times per case. The 4 loose fill cushioning materials were placed one at a time with 1 inch thick, as shown. The 3 board form cushioning materials were placed one at a time with different thickness, as shown. It was hard to keep the thickness the same. For each loose fill cushioning material, the average of 20 impact accelerations was used. The biodegradable foam absorbs shock the most at about 20%. It is interesting to see that the shock absorption of the foam at ambient or about 61% relative humidity is comparable to those at 95% humidity. For the board cushion, biodegradable board again is the winner. It absorbs far more shock than the rice hull board and mushroom board. The following conclusions can be made from this study. 1. Temperature dissipation rate for PETG is much faster than that of corrugated. 2. As temperature rises, the tensile strength rises in both PETG and corrugated. But the increase rate of PETG is higher than that of corrugated. 3. Biodegradable foam does not dissolve at 95% relative humidity. It also gives the best shock absorption.